Today we will be solving a problem that has been vexing engineers and masons alike. Masons and engineers don't see eye to eye on this problem, and each one has their own reasoning or understanding. During this problem solving, we will also see linear problem solving versus exponential problem solving, performance graphs, and nonlinear equations in the second order, and all this through the lens of ancient wisdom. First, the problem. There is a wash basin to be fixed on a wall, vertical wall, and the wash basin is 30 inches wide and 24 inches in length. It is weighing 15 kilos. Now the choices are two. The first choice is a 9-inch bracket, and the second choice is 12-inch bracket. There will be two brackets, and they will fix it widthwise, which is on the 24-inch side. The brackets will be fixed to the wall using 4 screws each. The area of operation or area of contact with the wall remains the same, does not matter what bracket. Now the question is, which bracket is better, stable and stronger given this situation, 9-inch or 12-inch? You can make your own assumptions. The interesting thing here is that masons almost unanimously go in for the 12-inch bracket, whereas engineers most of the time opt for 9-inch bracket. Engineers say that a 9-inch bracket is going to be sturdier, stronger and better, whereas masons say that 12-inch bracket is the only workable solution. Obviously, the answer should be one, single answer and a reasoned answer. So let us see what are the reasons and how we can solve this vexing question. And in the first place, why does the difference in opinion occur at all, whereas both masons and engineers come from the same family? The diagram for your reference is given in the comment section. Now interestingly, you will see that the contact area is the same. So does not matter what bracket, the force that will be exerted on the wall by the weight of the basin is going to be the same. And whether you fix the basin with just 2 screws or 4 screws for that matter, or use 9-inch bracket or 12-inch bracket, the force downwards is going to be same. So far so good, but the God is in the details. The overall force that is going to be exerted on the wall is divided into 2 forces. One is a shear force which works vertically, trying to break the screws, whereas there is second force which is called as bending motion, which works at 90 degrees to the earlier one and tries to pull the wash basin out of the wall. And these are the 2 forces, though their sum total will remain the same. How will these 2 forces be supported or are divided will make out what is the better option. And this is a problem that can be solved classically by using the reductio absurdum method. Reduce the problem to an absurdity, reduce the problem to the lowest area, or as in case of sevenfold method of ancient wisdom, reducing the problem to 0. And how do we reduce the problem to 0? We say that, let us put it this way, that the whole basin is put up on the walls using just 4 flush screws right into the body of the wash basin. Those who say that 9-inch bracket should be sturdier than 12-inch bracket because the length is less, the same logic follows that 8-inch bracket would be sturdier than 9-inch, 6-inch bracket would be sturdier than 8-inch, 3-inch bracket would be sturdier than 9-inch, and screws in the wall would be the most sturdy of them all. But let us see, does this happen? No, because screws directly in the wall, they take up the shear load thoroughly, they take up the shear load well. But what they don't take up so well is the bending motion, and the chances of the wash basin falling forward, extracting the screws from the wall, is much higher. Now, what is the bending motion or bending motion coming from? It is coming from the weight of the wash basin that is not supported, and the weight of the wash basin works through its center of gravity. Where is the center of gravity? It will be at 12 inches from the wall, because the overall length is 24 inches. If we see the other argument, that the 12 inches one is better than the 9 inches bracket, again we use the reductio absurdum method. Would that mean 15-inch bracket would be better than 12-inch, or 18-inch bracket would be better than 12-inch, or 24-inch bracket would be better than 12-inch? No, because as the size of the bracket increases, the weight of the bracket also would increase, and that additional weight would have to be supported by the bracket. So obviously there is a golden mean or golden length at which the bracket needs to be cut, and that golden part we have to see, and this is exactly where most of the mistakes are happening, because we are approaching the problem in a linear way. Bigger the better, shorter the better. That is the idea that we are having, which may not be the case. The shorter may keep on becoming stronger till a point, and then it would become weaker, or on the other side, the longer one till a particular length is reached would be strong, and then progressively would become weaker. For example, in traffic questions or traffic problems, it is said that speed is one variable for accidents. More the speed, more the accidents. But this goes on till a mean speed, and after that, even if the speed increases, accidents reduce. The performance graph drops. So the answer is that till the mean speed, the accident rate goes on increasing. After the mean speed, or after the mean speed is reached, even if the speed of the vehicles goes on increasing, number of accidents go on reducing. There is a inverse relationship, or there is a relationship that keeps on changing, and this is exactly what happens when it is multivariable problem. So now we have gone from single variable problem to a multivariable problem, and now we will see at the second order. The center of gravity of any mass is the one from where the gravity works and pulls the object towards the ground. So the length of the bracket would be useful to stabilize or reduce the bending motion till the point the center of gravity of the basin is reached, which is at 12 inches. Any increase in the bracket thereafter is going to be counterproductive, because it will keep on adding weight without adding any product usage, and this 12 inches is going to go to oppose the bending motion. So though the area in operation or area in contact with the wall remains the same, the stability of the basin would be better because the bending motion would be better supported by the 12-inch bracket. And as far as the shear load is concerned, both the brackets are supporting the shear load in a proper way given the same area. So shear load would be similarly dealt with by both the brackets, whereas the stability part, the bending motion part, would be dealt better by the 12-inch bracket, and that is why 12-inch bracket is the answer. Answer is not the point. Why of that answer is important, because it is why that segregates the scientific community from the common people. Many people say this is common sense. No, it is not common sense. Common sense is the sum total of preconceived notions of common people, or stereotypes or biases of common people, whereas science does not go with the common sense. Common sense would be at one time common sense was that heavier objects would fall faster and lighter objects would fall slower, and this was common sense held for 1300 years. Only when Galileo dropped two balls, one bigger and one smaller, from the Tower of Pisa, and both of them came down at exactly the same time, that this notion or this common sense was destroyed, and science, so to say, was born. Because science does not go with common sense, science only goes with knowledge. It also does not go with any belief. Do it, show it, check it, understand it, and that is why this becomes a vexing problem. And once we understand the root of this problem, we are able to solve not only this problem, but generalizing it, we can solve any number of problems which fall under this category. That is the importance of this vexing problem of bracket. Namaskar.